If there is any point in common with the feasible region and the line, then we say there is no maximum value. So the maximum availability in the mixture is 8 units for vitamin A and 11 units for vitamin B. When I say minimize the cost of such a mixture, we are going to find out the minimum value for the given set of linear programming problems. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to learn the linear programming problems for unbounded region. So what do you mean by this unbounded region? So until here, we have solved a linear programming problem, a set of linear programming problems where we used to get the feasible region which is bounded. That means it has the boundaries. But here, we will be getting the feasible region where we cannot have boundaries. So those regions are called as unbounded region. Then, whenever the feasible region is given, the first thing is we will find the corner points. Then we will decide it whether we want a maximum value or the minimum value. But in the case of unbounded region, even though we have the corner points, but we will decide it whether m is a maximum or minimum, or whether it is not a maximum or minimum value for the given linear programming function. So let's see what happens if the feasible region is unbounded. So the rule says, suppose we have m as the maximum value to the curve or to the feasible region, then we need to solve a linear equation by taking ax plus by greater than m. Then we need to find out ax plus by greater than m by constructing a line with the help of its coordinate. That is, after finding the corner points and finding the maximum value, we need to construct one more line by taking the linear function. What is the linear functions we have? Z is equal to ax plus by. Suppose I get some 10 as a maximum value, then I have to draw one more line in the graph taking ax plus by greater than m. So when I draw that line, when there is no point in common with the feasible region, that is, the line ax plus by is equal to m should not pass through feasible region. If does not have any common point, then we say that m is the maximum value of z. If there is any point in common with the feasible region and the line, then we say there is no maximum value. Similarly, when I say small m or any m which is a minimum value, then for unbounded region, we are going to construct one more line by taking the linear function as ax plus by less than m, where m is the minimum value after you solve the corner point table. So if you take the equation ax plus by less than m, and if you draw a line, that line should not coincide with the feasible region. If there is no point in common with the feasible region, then we say m is the minimum value. If not, then we say that m is not a minimum value. That means for an unbounded region, you are going to take the linear function less than m or greater than m. You are going to construct one more line to the graph. That line should not coincide with the feasible region. In that case, we call m as maximum or minimum value. If the line coincides with the feasible region, then we say that m is neither a minimum value nor a maximum value. Let us take few examples for this. Reshma wishes to mix two types of food P and Q in such a way that vitamin contents of the mixture contain at least 8 units of vitamin A and 11 units of vitamin B. Food P cost Rs 60 per kg and food Q cost Rs 80 per kg. Food P contains 3 units per kg of vitamin A and 5 units kg of vitamin B, while food Q contains 4 units kg of vitamin A and 2 units kg of vitamin B. Determine the minimum cost of the mixture. So, as the last statement says, here we are finding the minimum value for the given function. Now, so what is the Cost of food P 60 rupees per kg and food Q is 80 rupees per kg. So we are preparing food P as well as food Q containing a mixture of vitamin A and vitamin B. Now, the cost of the food P and food Q can be taken as linear function. So that is, we can take it as 60x plus 80y. Now we need to find out the minimum cost required to prepare the mixture. So that is, minimize z is equal to 60x plus 80y. Now what are the constraints we have? So that is, if I say food P and food Q, if this is your vitamin A and vitamin B, food P contains 3 units per kg of Food P contains 3 units per kg of vitamin A and 5 units per kg of vitamin B. Similarly, food Q contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. So these are the constraints we have. So then the mixture contain at least 8 units of vitamin A and 11 units of vitamin B. So the maximum availability in the mixture is 8 units for vitamin A and 11 units for vitamin B. So therefore, we will get these two as a linear equation. Hence, we can formulate this mathematically as minimize z is equal to 60x plus 80y subject to the constraint 3x plus 4y greater than or equal to 8. When I say minimum, see here, the question is given the mixture contain at least means minimum 8 units. That means it can also have more than 8 units. That's why we are taking here greater than or equal to. And here also for vitamin B, it can have at least 11 units. At least means again it is a minimum quantity. So it can have more than 11 units also. So therefore these are the linear inequalities. So solving these two linear inequalities by taking x and y coordinate, we can clearly see. So this is the point we get here. Now as I said here, if you take 3x plus y, 4y is equal to 8. If you put x and y as a coordinate, if you take x as 0, then y you will get it as 2. If you take y as 0, then you will get it as 8 by 3. Okay, so 8 by 3 is the unit. Similarly, 5x plus 2y, if you have as 11. So if you take x and y, and if you take x as 0, you will get y as 11 by 2. And if you take y as 0, you will get x as 11 by 5. So you can also take other quantity to find the value of x and y. So here points are given. So you can clearly see for the line 5x plus 2y is equal to 11. The points are 0, 11 by 2 and 2, 1 by 2. And here they have taken 2, 1 by 2. That means for x they have taken 10. So obviously you will get 2y is equal to 1. So y is equal to 1. So if you take x is equal to 2, you will get y is equal to 1 by 2. You can also take this point. So they have taken 2, 1 by 2. So these are the 2 points you will get here. So join this and extend until it touches the x-axis. Next we have one more point. So that is one is 0, 2, another one is 8 by 3. So 8 by 3 is almost 2.5. So 0, 2, 8 by 3, 0. So join this. Now coming towards the feasible region. As I said, both are greater than or equal to. That means for any line, if you have greater than or equal to some value, that means the region will lie above the line. So therefore, for this line also, the region will be above the line on the first quadrant, and for the second line also the region is above the line on the first quadrant. So obviously this is the common region for both the lines and it can extend until infinity. So therefore any points in this feasible region can satisfy the given set of linear inequalities. Thus this we call it as a feasible region. So we can extend the region also. Now here coming to the corner point, you have got the feasible region here. Next you are going to mark the corner points. What are the corner points here? So this and this. So I have stopped until here. As I said, you can extend the feasible region also. So you will not get any corner points after this. You can extend the area of the feasible region. Only you have 3 corner points. So the first one is 0, 11 by 2. Second one is 2, 1 by 2. Third one is 8 by 3, 0. Substituting it in the corner table, this is what you will get. And substituting the value. See here, our optimal function or the linear function is z is equal to 60x plus 80, where 60 is the cost of food P, 80 is the cost of food Q. Now, how many mixtures of food P and food Q are gone? That is x and y. Now, substituting in the value 8 by 3, we will get 60, 8 by 3, 3, 2, 8 is a 16, 160. Y is 0, so total 160. Similarly, if you take 2 and half as x and y, you will get the value as 160. If you take 0, 11 by 2, so this is what? 450. What is the thing we need to find out here? Minimum value. So, which is the minimum value here? 160. Now, we got the minimum value is 160. So, that is, we can say the minimum cost required for the mixture of food P and food Q. Now, once you get the minimum value, you need to take the linear function in the form 60x plus 80y less than 160. Why? Because the region is unbounded. Whenever the region is unbounded and when you are getting any minimum value, you need to take the linear function less than the minimum value and find the solution inside the graph. So, when I divide this equation by 20 completely, we will get the value as 3x plus 4y less than 8. Now, this is same as the line 3x is equal to 4y plus 8, isn't it? So, my graph becomes this one. So, here you can clearly see you have a red line whose equation is 3x plus 4y is equal to 8 here, and you have a dotted lines in black color which is 3x plus 4y less than 8. So, clearly see here the dotted line represents the line 3x plus 4y less than 8. So, the area will be below the line. So, the area will be below the line. So, none of the points here on the line as well as inside the feasible region coincide with the set of linear equation 3x plus 4y less than 8. So, if there is no point in common, we can conclude M, that is 160, is the minimum value for Z. If there is any point in common, we will say the linear function cannot have any minimum value. But clearly we can see here this line do not have any common point with the feasible region. The dotted line represent the linear inequality which is less than 8. So clearly less than 8 means no point will be in common with the feasible region. So the area will be below this line, hence it cannot touch the feasible region. So, there is no point in common. Hence, we can conclude that 160 is the minimum value for the given function. So, that means what we can conclude here. So, 160 is the minimum cost required for the mixture of vitamins for food P as well as food Q. Next question. Minimize Z is equal to 3x plus 5y subject to constraint x plus 3y greater than equal to 3, x plus y greater than or equal to 2. So, once you have a set of linear equation and a linear function, this is a function where we need to find out the minimum value. Let us solve these two set of inequality. X plus 3y is equal to 3 means we have the set of equalities as xy. If x is 0, y is 1. If y is 0, x is 3. So, it is 0, 1 and 3, 0. The next one is we have x plus y is equal to 2. So, clearly we can say when x is 0, y is 2. When y is, x will become 2 when y is 0. So, therefore, the points are 0, 2 and 2, 0. When you plot this and clearly you see you have greater than 3 and greater than 2. That means both the lines, the feasible region will be above the lines. So, clearly you will get the graph like this. So, I have taken a graph 1, 2, 3, 4, 1, 2, 3, 4. For the first set of line 0, 1 and 3, 0, join the line. For the second set of line 0, 2, 2, 0, join the line. So, this will be the feasible region. So, you can also extend it. So, And you can clearly see you have the corner points, 3 corner points here. So one is A 3, 0, B 3 by 2, 1 by 2. So this is you will get here. You can clearly see this is 1.5. 1.5 in fraction we represent it as 3 by 2 and this is 0 0.5. 0 0.5 is nothing but 1 by 2. So I have taken in fractions here. So by looking at the coordinates and distance from x-axis and y-axis, you can recognize the coordinates of point B. Now we have the corner points. Substitute it in the table. So 3, 0, 3 by 2, 1 by 2, 0, 2. Substitute these coordinate in the function z is equal to 3x plus 5y. See, we have 9, 7, 10. What is the thing we need to find out? The minimum value. Which is the minimum value? 7 is the minimum value. Now to conclude 7 is the minimum value, we need to take the linear equation in the form 3x plus 5y less than 7. So when I take 3x plus 5y less than 7, obviously I will take two coordinates here. So this dotted line will become the line 3x plus 5y less than 7. So when I say strictly less than 7, the area below this will be the solution for this set of inequality. Clearly you can see the feasible region do not coincides with the area under the line. So that means there is no point in common with the feasible region as well as this linear equation. So we can clearly say that 7 is the minimum value of z at the point 3 by 2, 1 by 2. Next one, minimize z is equal to x plus 2y subject to constraint 2x plus y less than or equal to 3, x plus 2y greater than or equal to 6, x comma y greater than 0. So we have a linear function z is equal to x plus 2y for which we need to find out the minimum value. 2x plus y and x plus 2y are the linear equations we have. We will see the graph of this function. On solving this, we will get the graph. So clearly you can see this is the line 2x plus y is equal to 3 and this is the line x plus 2y is equal to 6. For both the region, the area will be above the line. The common region will be this blue shaded region. Hence you have only two corner points here. So one is at A, another one is at B. So substitute it in the corner table, find the value of 6. So here you have 6 and 6. You can clearly see that you can take other value. So if you take it as any value as 2, 2 also, the value will be equal to 6 only because 2 plus 2 into 2 is 6 again. So we have at any point here, at any point on the line, the value will be 6 only. So hence we can conclude here the minimum value of the function is 6 only. Next question. A dietitian wishes to mix two types of food in such a way that vitamin contents of the mixture contain at least 8 units of vitamin A and 10 units of vitamin C. Food 1 contains 2 units per kg of vitamin A and 1 unit per kg of vitamin C. Food 2 contains 1 unit per kg of vitamin A and 2 units per kg of vitamin C. It cost rupees 50 per kg to purchase food 1 and 70 per kg to purchase food 2. Formulate this as a linear programming problem. Minimize the cost of such a mixture. Again, when I say minimize the cost of such a mixture, we are going to find out the minimum value for the given set of linear programming problems. So what is given here? The mixture can have at least 8 units of vitamin A. So the availability of vitamin A is 8 units. That is minimum. And that of vitamin C is 10. But food 1 and we have food 2. So food 1 can have 2 units per kg of vitamin A and 1 units per kg of vitamin C. Food 2 can have 1 units per kg of vitamin A and 2 units per kg of vitamin B. So therefore this will be the linear equation for vitamin A and this is the linear equation for vitamin C, which is a constraint because it can have at least 8 units and this is at least 10 units. the mixture can have this much. Now, also we have the cost per kg for food 1 is rupees 50 and for per kg for food 2 is 70. So, the mixture can contain x units of food 1 and x units of food 2. So, for 1 unit it is 50 per kg for food 1 and 70 per kg of food 2. So, how we can represent a linear function? Z is equal to 50x plus 70 y. Okay, so x units of food 1 and y units of food 2, and we need to minimize this cost based on this credential, that is the restrictions. So, let's see how we can formulate this. So, this is where we can formulate the problem as minimize the cost. Z is equal to 50x plus 70y subject to the constraint 2x plus y greater than or equal to 8. When I say at least, means it's a minimum value. It can also have greater than 8. So, we will have to write greater than or equal to. Similarly, x plus 2y is greater than or equal to 10 and x comma y obviously greater than 0, which means we are counting, and graphically it means the solution lies in first quadrant. So, when we solve 2x plus y greater than or equal to 8, so if I take x and y value for this, if x is 0, y is 8. If y is 0, x is 4. So, for the first one, we have 0, 8 and 4, 0 as the coordinates. Now, when I say second one, here if I take x and y, if x is 0, y is 5. If y is 0, x is 10. So, we can take 0, 5 and 10, 0 as the coordinates and then join the line. Let's see the first line, 2x plus y is equal to 8. So, this is the line 2x plus y is equal to 8. The coordinates are 0, 8 and 4, 0. For the second one, we have 0, 5 and 10, 0. And clearly we see that greater than or equal to means the region for both the lines will be above the region. So, therefore, the common region for this line also the area will be above this. And for this line also the area will be above this. But which is the common region which can satisfy both the line? The shaded region. Here, the shaded region in blue represents the feasible region which satisfy both the linear inequalities, and we can extend the region also. So, here I have just taken only this region and my corner points is A, B and C here. A is 0, 8, C is 10, 0, B we can find through graph. So, you can clearly see here distance of the point from x-axis here. So, this is 2. Okay, and distance from y-axis. So, this is the distance from y-axis which indicates 4 and distance from x-axis is 2. So, 2, 4 will be the coordinates of point B. Now, we have all the corner points. Substitute in the corner point table. We have 0, 8, 2, 4, 10, 0. We have a linear function 50x plus 70y. Now, substitute it. For first one, 50 into 0 plus 70 into 8, 560. Second one, 50 into 200, 70 into 4, so we have 28, so 380. Next 10, 50, 500, 0, 500. So, we need to find out the minimum value. Which is the minimum value here? 380 is the minimum value. Now, since the region is unbounded here, we need to have one more set of linear equation. Which is that linear equation? We have to take the linear function 50x plus 70y less than 380, because we are telling 380 is the minimum value and we need to find out this line should not have any common point with the feasible region. Let me divide this equation by 10. Then what happens? I will get 5x plus 7y less than 38. So, by taking the points as substituting the value of x and y, we can see this line which is in dotted line. So, the line which is representing the dotted line will give you the equation for 50x plus 75 less than 380. When I say less than 380, the area below this line, below this dotted line represents the solution for this set of linear equation. And you can clearly see none of the points here coincides with this region. So, there is no point in common with the feasible region. Hence, we can clearly conclude that 380 is the minimum value for the given linear programming problem. So you can also say, since this point is coincide with this line also here, isn't it the point coinciding with the feasible region? No. When I say dotted line, the line along the points will not include, because we have clearly strictly less than 380. When I say strictly less than 380, no point on the line will be the solution. Only the points below the line will be the solution for the given equation. Hence, there is no point in common with this region. Hence, we can clearly say that 380 is the minimum value. And according to the question, they say that we need to find the minimum cost of a mixture. So what is the minimum cost of a mixture? Rupees 380 is the minimum cost of the mixture where we can mix the foods of type 1 as well as type 2. And all these here represents the cost of mixture including type 1, type 2. So thus we can clearly say here we can mix 2 units of food 1 and 4 units of food 2 to get a minimum cost of a mixture at rupees 380. So hence here in the chapter linear programming problem, we have solved the set of linear equation using graphical method, that is finding the optimal value. Optimal value means finding the maximum or minimum value for the linear function, and optimal solution means at which coordinate you are getting the optimal solution. So that is what we will find through LPP. So that's what we can conclude. Linear programming problem is nothing but finding the solution or finding the optimal value. Optimal value means finding maximum or minimum value for a linear function subject to set of linear inequalities which are called as constraint. So this is how we are going to find, and hence we have both bounded region as well as unbounded region in a graph. So for bounded region, we are going to find the corner points and substitute the corner points through the linear function and find the value of maximum or minimum value. And when I come to unbounded region, again we will take the corner points, we will substitute it, we will find the value of z as minimum or maximum. To know that or to conclude it whether it is a minimum or maximum, we need to draw one more line satisfying the equation ax plus by greater than m or ax plus by less than m. When there is no point in common with the feasible region, we can surely say the given value is the maximum value or minimum value for the LPP. And hence this is all about the linear programming problem. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.